In this lesson, we're going to examine the normal distribution in a greater detail here. Every question we did yesterday involved situations where we wanted to calculate the probability, but things landed on exactly 1, 2, or 3 standard deviations, our special numbers of 99, 95, and 68. But the problem we might be asking ourselves is what happens if we don't land on one of those special numbers? So there's a way around this. We call it a z-score. And now we've talked about z-scores in this course before. And we talked about how one person compares to everybody else, a single piece of data compared to all the other pieces of data. Well, we can use that idea in relation to probabilities also. So just a quick reminder that a z-score is your value minus the mean divided by the standard deviation. Okay? Sometimes we have positive z values, which means we're above average, negative z values, below average, and most of the time our z values will be between positive 3 and negative 3. In other words, 3 standard deviations above or below the mean. When we calculate that z-score, let's say we come up with a z-score of, random number here, 1.2. Well, that tells me that, here's my mean, the middle, my z-score is somewhere over here, just more than 1 standard deviation above the mean. Based on that z-score, I can actually calculate the proportion of data that's down in this interval, or I could easily calculate the portion above that z-score in that interval. Okay? And I could do that by using a table. Okay? There are tables of values that show us all the possible z-scores that you could possibly have and the probabilities that coincide with them. And by probability, we mean proportions. Now, tables are fine, and if you go off down the road to university or college, you might be using tables, but we have some technology available to us which will save us from doing this. So we're going to be using our graphing calculators today. Okay? So if you don't have one at home, or you haven't downloaded the e-version of it, you're probably going to have to come in and try this at school, but we'll go through it today to see how it works. So, z-scores. Let's take a look. Okay, the whole idea of the z-score on our calculators is using something called the normal CDF function. The normal CDF stands for the normal, obviously, and CDF stands for cumulative distributive function. What this function does is it accumulates the amount of data in the normal distribution from the left-hand side. So for instance, it might add up this piece plus this piece plus this piece plus this piece plus this piece, all the way up to the interval that you want. So if you want it all the way to here, you'd have to keep adding all these pieces in here, and it will do that for you. It's saving you from having to look up the score in the z-score table, or it saves you from having the situation of not landing on a perfect number of standard deviations. So we're going to take a look at an example to get us started on this. The times that people wait in a grocery checkout line is normally distributed. In other words, if it's this normal distribution. The mean waiting time is 4 with a standard deviation of 1.15 minutes. What is the probability that Jack will be through the line in less than 5 minutes? So if we were to draw this based on what we did yesterday, standard deviation is 4. Jack wants to be less than 5 minutes. He's over here. One standard deviation is 1.15. So in other words, if I were to put a standard deviation here, I'd be at 5.15. So we've kind of just slightly missed that perfect number. I want to figure out how much data is accumulated in here. So my notation, probability that x, my value, will be less than 5. Okay, there's the notation. You can use the calculator to do the work. So this is all you really have to write down, what you're doing, and then the answer. Here's how it's going to work. So we'll go to our technology screen here. Graphing calculator. Turn it on. Clear memory like usual, second plus 712. To do a normal CDF, we're going to go to distributions, which is right here in blue above vars. So second vars. We're going to do number 2, which is a normal CDF, cumulative distributive function. So you can either go down to it or press the number 2. And then we have to tell the calculator what parts we want to include. We have to give it boundaries. So the graphing calculator is set up to go to the infinite numbers. And by infinite means all the way to the left and all the way to the right. The lowest number the calculator can possibly think of is negative 1 E99. In other words, negative 1 times 10 to the 99, the biggest possible negative number you can think of. In our question, we have to tell the calculator, I want boundaries that go from negative 1e99 way over here all the way up to 5. That's my upper bound. Okay, the mean we are given is 4. My standard deviation is 1.15. Okay, so the only thing we really have to change ever will be boundaries, and then the information we're given, the mean, the standard deviation. We're going to go down to paste. It's going to say, is this what you want to do? So we'll press enter and say yes. And there's my answer, 0.8077. And we're going to write that down. And then we're done. That's it. We figured out the probability that he has to wait less than 5 minutes. Okay. We'll try some more just to get the hang of how this calculator thing works. So our region receives an average of 5,100 millimeters of rain annually. Annual rainfall is soon to be normally distributed. Standard deviation of 150. Find the probability that A, more than 5,500 millimeters of rain. So I want to be greater than 5,500. So if I'm thinking about a graph, down the middle is my mean, which is 5,100. And I want 5,500 all the way up to here, which theoretically goes to infinity. I can use my calculator to do that for me. We're going to go back to our normal CDF, so second vars, number 2. Now this time our boundaries have to start at 5,500 and go all the way up to positive infinity. So the way we're going to show that is start at a lower of 5,500, and then to put in our upper, we're going to have to put in the biggest number the calculator could possibly think of, which in this case is 1, and then E, and that's using the second comma. You see how it has a little E right here? We're going to use that. 99. It's the biggest possible number the calculator can think of, the highest upper bound. We were told the mean was 5,100, and our standard deviation was 150. Paste it, enter it, check it off, and our probability is 0.0038. Done. There's a less than 1% chance that you can get more than that amount of rain in an annual basis based on what's happened in the past. Let's try B. Less than 5,000. So X less than 5,000. Okay, calculator. Second, vars. Normal CDF. I want to go from 0 to 5,000, or actually as far left as I possibly can to 5,000. So we use negative 1 E99 up to, I want to stop at 5,000, that's my upper boundary. My mean and my standard deviation stay the same. We'll paste it, and 0.2524. Okay. So usually you're either using negative 1E99 for less than questions, or positive 1E99 for greater than questions. The only difference is the letter C, one like this, where I want between. Well, the nice thing about between questions is that I'm being given my boundaries. I want to be at least 4,800 and no more than 5,300. Well, that's my lower and my upper. So again, real quick. Sorry. Normal CDF, 4,800 to 5,300 mean standard deviation, paste, enter. And I get 0.886. And that's how we use our normal CDF function. Now, all the questions we did yesterday that were nice standard deviations, 1, 2, and 3, you could use your graphing calculator for. I wanted to get you used to where these numbers are coming from, so we have this pattern. And if you can remember the 68, 95, 99, it'll save you some time because there are some really quick answers. But I'm totally fine with using the graphing calculator to do it also, because it gets you the same answer. In fact, a slightly better answer. Okay, let's try some different things. Students' marks on the quiz were normally distributed with a mean of 70 and a standard deviation of 5. What percent of the students obtained a mark above 76? In other words, what's the likelihood of getting more than 76? Well, graphing calculator. Normal CDF. Number 2, I want to go from 76 up as high as I possibly can, which in this case is 1E99. Our mean was 70. Our standard deviation, that's a 7. 70. Standard deviation is 5. How many kids got above 76? 0.115. or as a percent, 11.5%. All right, B, the top 10% of students don't have to write the next quiz. Above what mark are these students? Now, this is a different kind of question. It's not a normal CDF. Because what I'm saying is, back to our picture again here, our mean is 70 and our standard deviation is 5. The top 10% of students don't have to write the quiz. In other words, I want to know what number goes here. Is it a mark of 75? Is it a mark of 80? Is it a mark of 82? I want to know what goes here such that there's 10% left over in that curve. So only 10% of students do it. In other words, I'm really asking the probability that x is greater than a comes out to 10%. This is a backwards question. I know what the probability is. There's 10%. What I want to know is what value makes that happen. So to do this, we can use our calculators, but we have to do a different kind of function. We have to do the opposite of normal CTF. So to do that, we're going to use second vars, but we're going to use number 3, the inverse norm, the opposite of a normal CTF. So let's go to number 3. Now here's the trick. With the inverse norm function, what you have to do is give the area. How much of the curve do you want? What percentage of the curve do you want? But you have to do it from the left-hand side, because that's how the calculator works. In other words, how much data from the left do you need before you get to A? Now we said there was 10% of our data above, which means there's 90% of the data below. Okay, so our area is 0.9, 90%, 0.9. Our mean, well, we know our mean already, it was 70. Our standard deviation was 5. We're going to paste it like normal. And our mark that you have to get is 76.4. So anybody who scores 76.4 or higher will be in the top 10%. So basically 76.5, right? If you're below 76.4, you're in the bottom 90%. The trick here is you have to make sure you're using the area from the left. With that in mind, let's look at part C. The bottom 25% has to come into Math Hope tomorrow. What mark are these students going to get? Well, again, if we go to our graph, we're thinking about the bottom 25%. That's here, these people. I want it to be 25%. Okay, what value corresponds to that? It's called the letter B. In other words, less than B has to come out to 0.25. I want to find B. Calculate our question, and again, it's an inverse norm because I know the percentage. I want to find the value. Okay, so number 3, my percentage this time from the left-hand side, well, from the left up to B is 25%. So I'm putting in 0.25. Mean standard deviation are the same. Calculate. If you scored 66.6 or lower, you're in the bottom 25%. And if you're above that, you're good for tomorrow. And last one of these. What score must be achieved to be at the 80th percentile? Well, a percentile is basically the same thing as saying a cutoff value or a percent. If I want to be at the 80th percentile, that means 80, there's about right there. There should be 80% of data here and 20% over here. That's the cutoff between them, the 80th percentile. So if I call this one C, really what I'm asking is what probability, being less than C, comes out to 80%? Again, an inverse norm question. All right. Second vars, inverse norm, 0.8 from the left. So it's basically the same thing as saying top 20% or bottom 80. And we get an answer of 74.2. So if you were to score 74, you're about the 80th percentile. 75, you're in the top 20%. Okay, last example. I get you to try all the different parts and pieces yourself. Can you figure out which one you need to do? The number of red blood cells is normally distributed with a mean of 4.8 and standard deviation of 0.3. What percent of people are between 4.75? Okay, I'm looking for percent, so I'm looking for a probability. I want to be between these numbers. It's straight up graphing calculator. Second vars. I'm doing a normal CDF because I'm looking for the probability. I was given boundaries of 4.7 and 5. My standard deviation was 4.8. Sorry, my mean was 4.8. My standard deviation was 0.3. And hopefully you get 0.3781. Okay, B. What proportion of people have a count less than 4? Proportion, another way of saying percent or probability. I want to be less than 4. So on my vars menu, I need to go from -1 E99 up to 4. So I'm going to go from the far left as I possibly can. And we hopefully get 0.0038. C. To be in the top 5%, what count would someone need to have? Okay, so think about my graph. Top 5% is up here. I'll call this value A, which means I have 95% down here. So I'm looking for the probability of being greater than A being 5%. Okay, what do I need to do to that? Inverse norm. But from the left, I need 95% of my data. And our mean hasn't changed. Our standard deviation hasn't changed. Our value is 5.29. D to be in the bottom 10%. Well, okay, so it would be less than B. I want it to be 10%. Okay, on our picture, I'm really thinking about this is B, this is 10%. Well, again, that's an inverse norm question, and I know the data from the left because I can see it, it's 10%. So the only change I'm making is that one. Our value is 4.42. And the last question. What would their cell count be if they're in the middle 50%? Here's the thinking question for you. The middle 50%, what does that look like? Well, that's from here to here. I want 50% of my data to be here. In other words, I want my interquartile range from Q1 to Q3. Okay, if we call these the letters C and D, how much data is below C? Well, there's 25%. Which data above D is also 25%, right? It's equal. So if I'm thinking about C, I'm really thinking about I want to know what's the likelihood I'm going to be between C and D. C is an inverse norm question. Okay, from the left, I want 25% of my data. So 4.60, if you will. And if I'm doing D, D would be from, again, the left. I've got 25 here, plus 50 here. So in other words, there's 75% on the left side. Or if you will, there's 25% on the right side. So again, inverse norm. But this time I want 0.75. And I should get 5. And you're done. Okay, that's what we use in the normal CDF function on our calculator and the inverse norm. Forwards if you want the probability, inverse norm if you have the probability. Just be careful you're working from the left. Homework questions to try are these ones, all with the graphing calculator basically. Use it, get comfortable with it. It's a tool that we want to use as much as we can because we have access to it.